I pressed the go live button.
Yay.
I feel like I'm missing something. I'm forgetting something huge. I've got my audio recorder set up. I've got the OBS set up. I've got the Astronomy Cast chat
I
live.
don't have my notes in front of me. I need to fix that. So I know what I'm missing. I don't know what
Yeah.
you're missing.
Yeah, I don't know. There's something. There's something. Anyway, I'm sure at a certain point I'll be like, oh, of course, I completely forgot to X.
Yeah. These things happen.
I wish there was some kind of list that you could check.
We have one on Trello, dude.
A list that you would somehow check, like a list check.
On Trello.
I don't know. Sounds complicated. Sounds too organized for me.
Oh man, speaking of organization, to all of you good folks over on Twitch, thank you for being here. And if you're trying to figure out where Daily Space went, it's running after Astronomy Cast today. So any of you out there on YouTube or Twitch, after we're done recording Astronomy Cast, I'm going to record Daily Space because sometimes chaos occurs. It's good chaos, people. It is good chaos. It was
Like,
just chaos.
you guys we're still just so excited about the SN15 landing that you just couldn't even record this morning. You're just like,
Exactly.
No, we just can't do it. I'm just so excited.
So did you do the same thing I did and just sit there going, is it going to relaunch? Is it going to relaunch? I see those flames.
I know. It was on fire, and I'm just
Yeah.
like, it is only a safe landing now 3 to 4 hours after the fact when they've detanked the entire rocket, and it is safe.
Yes.
That is a successful landing. It just
Yes.
on the pad on fire, it on the pad slightly leaning over.
It wasn't leaning.
No, I know this time it wasn't. So it looked good, and the landing was super soft. It really was a really nice landing. But still, absolutely. I was watching that and just going, this is not a bird in the hand. This is still
a fire.
Yeah, that rocket is on fire.
So the other thing, I mean, I'm glad I wasn't the only one. I was watching the NASA spaceflight stream, and I heard someone comment on air over there about this too. Like, I was watching going, okay, are Zeus and Apollo going to run out? Are Zeus and Apollo going to run out? And apparently this is the new extra thing to look at, which
What's Zeus and Apollo?
Oh, they're so SpaceX has two of Boston Dynamics doggos.
Oh, right. The robot dogs. Yeah, of course.
Yeah. And so they use them to explore the pad when it's not yet safe for humans. So they have those as well as a series of drones.
Yeah.
And I was like, I want to see the robot doggos. And I did not see them, but I was deeply amused that like I was not the only one on stream watching for the robot doggos. Are we 604 today?
605.
Dang. Okay.
Yeah.
Okay.
Yeah. But every part, I mean, it would have been nice if there wasn't as much fog and low cloud cover so we could actually see the whole flight.
Yeah.
It would have been nice if the camera hadn't been cutting off many times during the flight.
Did you see where they put the camera?
Yeah, on the flappy. So
Flap.
you could sort of see it, the whole horizon rolling up and down as it was going. That was great.
Yeah. So I am clearly overly enthusiastic.
Hence the later recording of Daily Space.
There were other reasons, but that definitely
That's the one I'm going with.
Okay.
Yeah.
That
you guys
works for me.
You're all so excited. You just can't.
We can't control ourselves.
Yeah,
well, and
exactly.
The other big thing is I really want to see Tianhe come through the atmosphere with that rocket it failed to fire correctly.
Mm-hmm.
And I know the probability is low. The probability of being hit is as close to zero as you can get.
Yep.
But I want it to happen over land and harm no one, but produce amazing videos.
Yeah. You know what? I'm going to give you a pronunciation here. So it's Tianhe.
Oh.
Yeah.
Okay, thank you.
Yeah, so it's not hey, te. It's like chang,
Okay.
tian, he.
Okay.
Yeah.
Why don't they spell them with the same? Never mind. I want somebody's language to be phonetic.
Spanish is pretty good. Spanish is phonetic. Like, once you learn how to read all the letters in Spanish, they're always
Which
the
I
same.
haven't.
Yeah.
Okay.
Yeah,
That's good to
like,
know.
you can literally just read out the words in Spanish. You can pronounce anything if you just read it out. Do I have my water? I have my water. It's not totally full, but I have some water.
I have my caffeine. It's in the cold variety instead of the hot variety because I ran out of time to make the hot variety.
Tesla Ranger is saying that Zeus and Apollo were the names of Higgins Dobermans on Magnum PI. So that must be it.
I did not know
Yeah,
that.
I didn't know that either. That's awesome. I haven't said hello to people. Hello to Altman, Andy Cowley, Bill Sugden, Caleb Daniels, Coalfire, DPI 209, Guido Bieber, Henrik Bo Anderson, Ian Farquharon, Janelle Duncan, John Seville, Joyful Running, Magnus Timer Jensen, Paul Disney, Rich Wilson, Tesla Ranger, Zapfan, Zog Harms. Also, I think there's some more there. But so I finished Shadow and Bone.
Mm-hmm.
Meh. It was fine. It was all right. You know.
It's just typical young adult fantasy fiction.
Yeah. It was just fun. I'll give it a meh. Couple of things were kind of cool, but the world building was kind of interesting. I can see there's a big controversy online because of how much like Avatar: The Last Airbender it is. So with the literally just fire bending, air bending, so on and so forth. Dark bending, sun bending, but they don't call it that, but still.
So have you watched both yet?
Both.
The Last Airbender and the new one.
Korra.
You're saying, sorry. I thought my brain skipped to Wu Assassins for some reason when you went to Airbender. Mm-hmm. You're still talking about Bones and Shadow.
Yeah. So Bones and Shadow's magic system is derivative of Avatar: The Last Airbender.
So there is a new series on Netflix. I don't know where it originated. It's playing on Netflix as so much is. Mm-hmm. That is called Wu Assassins that I made it 10 seconds into and went, this is not for me because of violence. But the promo for it was all earth, wind, fire, and water.
So maybe Invincible isn't gonna be for you because of violence.
Well, but it's cartoon violence.
Yes, it is.
So my brain, except for the Watership Down cartoon that was not suitable for 5-year-olds.
Yeah.
Mistakes were made, people. Mistakes were made. Other than that, I'm generally okay.
That was a scary movie to a 6-year-old.
Yeah. So like I was so traumatized by that movie that we were supposed to read as like one of the options off of a list, Watership Down in high school. And I was like, hell no, you cannot make me read that. No, still traumatized. Yeah. So anyways, yes.
Mr. X, Mr. Y saying that SN15 is still sitting there. That's fine, but it doesn't mean that it's not going to explode. Like maybe in 20 years, if it's still sitting there on some kind of pad, maybe a museum, every explosive part has been removed, we will count that landing a success. But we have learned our lesson at this point.
So I have to say, and we should record our actual episode at some point. One last thing. I was completely enamored with the alignment with the camera that NASA spaceflight had, the Hopper and SN15, where it basically looked like the original Hopper was wearing the SN15 nose cone as a hat.
Right, the angle was perfect. That's awesome.
Yeah, it really, really was.
All right, well, I think I've got my introduction written. So the thing that I've forgotten is not that. I'm ready, I think.
All right. I'm looking for all the record buttons. All the record buttons are mine. Test. Hello, Ali. Hello, Rich.
I'm also recording. Hello also to Ali and or Rich. Here we go. Astronomy Cast, episode 605, Sounding Rockets. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser, Cain, publisher of Universe Today. With me, as always, is Dr. Pamela, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well, and oh my goodness, you said that quickly today.
Did I?
You did.
Well, every time you say something 600 plus times, and you got to find a way to mix it up, to add a little, little something.
You're just in a rush to launch our topic. That's all. You're just in a rush to launch our topic.
Yeah, exactly. When you work in sounding rocket astronomy, you got to go fast. We'll just slow it down. We'll take our time. We'll get there.
When I laugh, it moves my camera. I need to not.
Yeah, I noticed that. For the people who are listening to this as a podcast, you have no idea, but definitely Pamela's entire scene is wiggling and jiggling around, sort of like a flap on SN15.
And we would like to congratulate the good folks at SpaceX for their successful landing of the SN15 Starship prototype. May all future rockets stand so steady.
Yes. Congratulations. Now do it from space.
Yes.
That's it. If you can do it
or
from
at least
space,
to space.
To space, I'm not too worried about. From space, that's the key. We've seen rockets go to space, but to see a rocket, a two-stage, fully reusable rocket system, go to space, return from space, land on the pad, that will be the game changer. So we can't wait to watch how that heat towel works. All right. Last week we talked about balloon-based astronomy. This week we're going to talk about putting rockets. Let me do this again. Last week, we talked about balloon-based astronomy. This week, we're going to talk about putting telescopes on rockets and making observations mid-flight. Welcome to the wild world of sounding rockets. And we'll talk about it in a second, but first, let's have a break. All right, Pamela, I think for people who aren't even familiar with this topic, it sounds impossible. You take a rocket that's on a parabolic flight, a relatively short flight measured in minutes, hours at the most, and you put a telescope on this rocket and attempt to do astronomy from a moving platform that is going to crash or land with a parachute at some point. How does this work? How is this even possible?
So what's amazing is it's not just astronomy. It's all sorts of different science. And while astronomy seems hard, what really got me is one of the other types of science they do with sounding rockets is on like the fertilization of different biologicals. And so the idea that you're launching critters that are alive and expecting them to successfully reproduce in that short period of time.
Yeah.
It's kind of amazing. So basically sounding rockets, which get their name from the same process as like sounding the bottom of the sea. The idea is that instead of probing the depths of the water, you're probing the heights of the atmosphere. These sounding rockets are giant model rockets for all intents and purposes. They have a solid rocket engine. So once you fire them, they go. They go at a lower velocity than your standard orbital rocket, which means you're not going to be quite as shaky and long enduring and violent of a takeoff. And they go up super fast. They then linger for typically, but like you said, it can be longer, but typically 5 to 20 minutes at their highest point. And then they come down and they expend a parachute. The engine drops one way, the scientific equipment hopefully flutters down gently. But as someone who's launched my share of non-successful model rockets, occasionally things go slightly sideways. But these are just like super simplistic systems, often actually like military overstock.
Right.
And students, researchers trying to study the atmosphere, all sorts of different people get to probe that place between how high the weather balloons go and how high you have to go to actually be a satellite that keeps orbiting.
So if you were to just compare, like we're all quite familiar with, say, a Falcon 9 rocket sitting on the launch pad.
Yeah.
If you were to look at a sounding rocket, what would it look like in comparison?
You'd have this desire to go, oh, aren't you so cute? um, they're like shorter than a house in some cases. They're small. They can be just 16 feet in length in some cases. They're much more similar to the Electrons, which are still essentially a really big sounding rocket. They do hit low Earth orbit with the Electrons, but they're tiny, and they're essentially the same thing as a military missile.
Yeah, I kind of imagine
discouraging.
I imagine like a scaled up version of like one of those missiles that, say, a fighter jet is carrying on the ends of its wing.
In some cases, they're almost identical.
or are.
It's not so much the ones that the fighters are carrying as the ones that some of the bigger bombers are carrying. You're talking basically 16 foot in length. That is essentially 5 meters in length for. Sorry, I did that wrong. No, I did that right. That's essentially 5 meters in length for the smaller ones. They do grow from there. And most of that is going to be your solid rocket propellant and engines. And then above that, you stick your experiments. And just like with any rocket, sometimes it's all one large experiment, and sometimes it's a whole bunch of little tiny experiments all going up together to get their 5 to 20 minutes of, microgravity experience and exposure to vacuum and exposure to a part of the atmosphere that's super cool because it's where aurora happens. It's where air glow happens. And it's someplace we don't otherwise get to really explore.
Well, and I guess that was my next question, was that typically we're very familiar with rocket launch facilities being Cape Canaveral, in South America, and so on. But these sounding rockets often launch from different facilities.
Yes. Yes. So you see them launching, White Sands Missile Arsenal is one place.
They got missiles, sure. Yeah.
Right. And it's cool because that particular location, they've launched undergraduate experiments, and then they come down and land out in the White Sands. And so you go trekking through the dunes to go grab your parachuted down experiment. They launched them also from Wallops on the East Coast. So you see these going up from still areas where you're not flying planes overhead, but you still see them going up from smaller facilities that are a lot more accessible for people that just need someplace to go launch.
And of one that we see a lot of launches from as well is the one in Alaska, Kodiak.
Yes.
Yeah. And there, I mean, that's the place you study the magnetosphere and auroras and things like that. So we know, a little bit of the launch facility. Let's talk a little bit about the kinds of flights that these rockets take. Are they straight up, straight down? Because normally when we think about a rocket launch, they're going mostly sideways to get into orbit.
And these do not. They go straight up, they come straight back down, and because of this essentially vertical trip that they go on, they hover above the point in the point on the planet above where they launched, essentially.
Right. That's very convenient that you don't have to go thousands of kilometers downrange to find your experiment.
Which is so much better than what so often ends up happening with weather balloons that can go across national borders and buy equipment. You do have to worry about how far things end up drifting due to parachutes, but that is a different problem. So if it's a nice still day, things go up. And the way it works is they don't literally hover. Nothing except for a hummingbird or a balloon literally hovers. But as they go up, they eventually dispel all their fuel and gravity takes over. They go slower and slower. And then as they start to run out of upward momentum, microgravity kicks in. And they're also at this point high enough up that they can start to do the vacuum experiments, do the ionospheric experiments, do biological experiments that need the microgravity environment. And during that 5 to 20 minutes it takes for them to do that final hit zero and then start back down. As they're coming back down, it takes them time again to build up velocity and to lose that microgravity environment, which really goes away as soon as the parachute deploys.
Right. I was going to say that if you've ever played Kerbal Space Program and failed to get your rockets into orbit, you've at least experienced what it's like to have that process where you're out of fuel on your rocket, and yet it's still gaining altitude because of the momentum left over. But as time goes on, your rocket is going up slower and slower until finally you reach the top point, your apoapsis of your flight, and then you start to come back down faster and faster and faster until you crash. And so, in fact, once the rocket engine turns off, you still got a long time of upward flight.
Yes. And the key for microgravity here is you are technically weightless as long as you are falling at the acceleration of gravity. And so the microgravity portion of your experiment can go from as soon as you start falling to when that parachute deploys and you radically change velocities. But microgravity is only part of the experiments they do. The other stuff that requires them to be in the highest points in the atmosphere, from 40 kilometers up to, they can go to 1,000 kilometers, but more often it's more like 120 kilometers.
So space.
So yeah. So space. Most sounding rockets confine themselves to that region between top of weather balloon and bottom of low Earth orbit. But it's within that area that you can do the, hey, I'm above the atmosphere, let's look at the sky in X-ray. Hey, I'm above the atmosphere, let's look at the sky in ultraviolet. Hey, I'm in the cool part of the atmosphere, let me study aurora, let me study the magnetic field. And so the same technology that gets used on satellites like TRACE and X-ray, all of those, not X-ray, TRACE and Chandra in the X-ray, all of these technologies got pioneered 5 to 20 minutes at a time on sounding rockets and then put into orbit when we knew they would work.
All right. Well, we're going to talk more about the kinds of experiments and what it takes to put your experiment on a sounding rocket in a second. But first, let's have a break. And we're back. So when we were talking about balloon-based astronomy, we talked about the interesting gimbaling systems, the procedures that they have to go through to try to balance out the various forces that a science payload dangling from the end of a balloon has to go through. So what do they do to compensate for a vastly different experience of trying to put your experiment on a rocket?
So here, at least they're dealing with stuff where you're not trying to narrowly focus the same way. A balloon-borne experiment that is designed to map out the cosmic microwave background has to have fairly precise pointing. But X-rays, as we've discussed before, really do not like to be focused. They kind of deny you. So if you can keep yourself reasonably pointed in the same direction, your reasonably not focusable X-rays are generally okay. Most of the experiments they're doing, however, it's more a matter of trying to see what the in situ experience is at that altitude. And sometimes they're just doing technological checks as well. So one of the experiments that was recently launched by a group of students was to see if we can start replacing some of the more dangerous thruster fuels we use in space with green fuels. And so they did test firings, they tried a solar blanket, and the goal was to simply see what kinds of, well, pollutants do you end up mucking up the outside of your experiment or your spacecraft. So you don't need to be stable, you just need to be stable enough that your experiment doesn't fall apart.
Right. And so I guess, I mean, I think that's a great example that you just need to be able to puff your propellant a couple of times when you're in the microgravity as you're falling down to Earth and detect whether or not that part is actually working. You already know what the chemicals are, and so you're just trying to find out, will you get the kind of change in velocity that you require? You talked about this idea of in situ, so you are sampling your local environment at various altitudes.
And for a biological experiment, I don't know, but if I was one of those little tiny itty bitty little, mostly not brain having biologicals, and you shot me upwards at 12G, once it got down to micro G and I'm no longer being squished, I'm going to be completely fine if I'm wobbling a little bit.
Right. And I guess that's one of the other issues as well as they got to deal with is handling the G's of the launch, because it can be extreme, but then also being able to handle the 0 G's as well and all the rattling and shaking and so on. And I guess that is also a good chance to find out if your experiment is going to be able to handle the rigors of a launch. So,
well, they have some amazing facilities, especially out at Goddard Space Flight Center, for shaking the bejesus out of something before they launch it into outer space.
Yeah.
It was on such a shake table that JWST experienced the loss of a few bolts in a way that we probably shouldn't get into today.
Yeah.
But what's more to the point is, while we can pull things down to vacuum on Earth, while we can shake things up on Earth, what we can't do is figure out, if you shake them, you vacuum them, and then you use them, do you get the data you want?
Right.
And it's that extra step that you can do with sounding rockets. You shake them, you accelerate them, and then you ask them to do their job. And with X-ray detectors, this is how we figured out just what would be possible and got to the point that we have the amazing systems we have today.
All right. Well, I want to talk more about what is possible to be done in using a sounding rocket that you can't do from the ground, but we're going to need to do another break. And we're back. All right. So you're sort of starting to lead into this about this idea of X-ray astronomy. What are the things that can only be done at that high altitude, that the sounding rocket regime, as opposed to the balloon regime and the orbital regime? What can you really only do with a sounding rocket, or best do inexpensively, affordably do? Yeah.
So, well, you can start to get into the infrared and microwave radiation with something like a weather balloon. You can't so much get into the X-rays. You can start to, but our atmosphere is pretty stubborn when it comes to blocking out certain shades of light. And again, this is something we are grateful for. X-rays are dangerous. They cause cancers. Small amounts, get your teeth X-rayed at the dentist, people. That level of X-ray is not bad. But if we were exposed to the amount of X-ray that is generally being produced in outer space, it would increase. We wouldn't be designed the way we are right now. We'd be something entirely different. But once you start getting up above the atmosphere, above that 40 kilometers that a weather balloon is happiest stopping at, then you can start to open up to the entire X-ray sky. And now you have supernova remnants. Mm-hmm. You have effects with the solar corona that you can't see otherwise. There's entire areas of science that we just otherwise can't do that we can start to do with sounding rockets for 5 to 20 minutes at a time. So again, test your equipment with this, then launch it and do the awesome stuff with the launch.
What do you think the future holds? I mean, we're starting to move into this world where we're seeing reusable rocketry. We're seeing smaller rockets that are capable of orbiting. Is there still a bold future for these sounding rockets?
I think how they get used is going to evolve over time. One of the benefits of sounding rockets that we haven't discussed so far is once you build something that fits nicely within the experimental compartment on a sounding rocket, it goes up, it comes down on a parachute, you tweak it, you relaunch it. These are experiments that can be run over and over again if you design them right. And if you're trying to test and do incremental design on that new camera, on that new sensor, if you want to sample the magnetosphere when it's most active and when it's most passive, this ability to repeat your experiments over and over with sounding rockets is something that's low cost and unique.
Yeah, that's really interesting. This idea that you can iterate, because iteration is absolutely key in any kind of engineering process that you're doing. So for example, you build some interesting infrared or X-ray sensor and you wonder, can it see X-rays? Well, you don't know because you have to go to space. But if you send this thing to space, then you can't get it back. So right. And so you put the thing on a sounding rocket, you send it to space, takes a bunch of pictures, it falls back into your arms. You take a look at the picture and go, oh, this didn't work, that didn't work. Let's make some tweaks. Then you put it under the rocket, you send it, you throw it up up into space. See, it takes a look around, and then it falls back into your hands, and then you just keep doing this incremental approach until you feel like you've got something that you're willing to throw so far into space that it never comes home.
I now have this mental image of a graduate student pulling away from the hands of their advisor and racing across the dunes at White Sands to catch their experiment that probably weighs more than they can hold.
Yeah, I'm sure it has happened more than once with them driving, going, no, don't let it crash, don't let it crash.
But I mean, just beyond the incremental design, our atmosphere is changing. There are so many different kinds of aurora. It's starting to feel like a month doesn't go by without this new aurora has been figured out.
You read the press releases today. A new one was discovered today.
Yeah.
When we're recording this. Yeah.
And so with all of these different atmospheric effects that change with the seasons, with the solar cycle, with the timing of when we get hit by a solar flare, being able to quick fire a sounding rocket with an experiment you have sitting there ready to go.
Yeah.
This gives us the chance to sample our changing atmosphere. And so it's iterative design on both sides, where it's space that iterates periodically and we need to sample those changes. And it's us being able to iterate the designs of our instruments and test things that, as you stated, we get back.
Yeah.
Don't catch your rockets, humans. Do not do this unless you're a SpaceX barge.
I do love that idea of seeing something interesting happening in the ionosphere, up in some aurora activity, you aiming your rocket and going, now, like, let's see what that is. And then away you go, and being able to get a device into the actual spot and see what's going on locally. Fascinating topic. Thank you so much, Pamela. And we'll talk to you next week.
It's my pleasure, Fraser.
Now, do you have some names for us?
I do, but as always, I have to go find the window now because I have buried the window.
In all your research.
Oh, my goodness. This is just such a cool topic as someone who flung rockets into space with or never launch earthworms, people. Never launch earthworms. When the teacher sends you out in the field to find a cricket and you find an earthworm, don't launch the earthworm. All right. That's all I have to say on that topic. But yeah, it's just like, these are the things I launched as a kid, just built bigger, and they're cool. And so, as always, we and our enthusiasm are brought to you by you. It's because of your donations that we're able to maintain our websites, edit our shows, and have an entire team of people that keep us sane. And this week, I would like to thank Ben Lieberman, Lori Kittleson, William, Robert Plasma, Joe Holstein, Paul Garman, Joss Cunningham, Les Howard, Emily Peterson, Keiko Seraf. I have no idea. Adam Annies Brown, Ed of the Universe, Just Joe, Gordon Dewis, Bill Hamilton, Helga Bjorkhag, Nicole Voracek, Frank Tippin, Jack Mudge, Joshua Pearson, Sydney Walker, Richard Riviera, Thomas Supstrup, Alexis, William Baker, Matt, Jean-Francois Regette, William Andres, Ron Thorson, Jeff Collins, Harold Bardenhagen, Jordan Turner, and Arctic Fox. Thank you all. Thank you for everything you do that allows us to do what we do.
Thanks, everyone. And we'll see you all next week.
And then they saved.
Still recording. Still doing the show. Yeah. Got another 22 minutes.
Okay.
Oh, hold on. Logan wants to poke his head up behind me. Can you see him?
Logan is, wow.
You can't. Hold on. People can't see him. Hold on. Let me see. Hold on. Wrong one.
This is blasphemy.
Where is he?
I remember when he was knee high to a grasshopper.
Oh, yeah. I don't have it on the camera. Sorry.
I have him on my camera.
Yeah, it's a different camera.
I know.
Yeah. Just come over here, Logan. Just come on over here. Just come say hi.
Hi.
Hello.
He's 6'4".
No, 4.
Four,
like 2.
3, 2, 6'2".
Dang, he's Kyle height now.
Yeah, he's big boy, and he's officially got everything he needs to graduate.
Oh, that's awesome.
Yeah. So he's done. Like we just found out yesterday that he's got everything he needs. I mean, graduating during the virus has been super weird, but
yeah. He doesn't get prom. He doesn't get your standard.
No,
that sucks.
Yeah, he gets vaccinated if he's lucky. That's what he gets. Yeah, and kicked out into the world.
I have to say though, for every introvert out there, this is a relief. This is like the first time in however long that introverts have been like, wait, no one's going to force me to? I can just stay home?
I'm encouraged to stay home.
Exactly. Yeah. And as someone who violently alternates between extrovert and, oh my God, please don't make me move out of my chair, I've kind of liked it.
Okay, I'm just doing my upload as well. And then...
Okay. And as a reminder, we will be doing Daily Space over on twitch.tv/CosmoQuestX directly following this show.
If you can get your excitement in order.
I'm allowed to stay excited for Daily Space.
All right. But just like to the point that you can be professional about it is all I'm saying.
Yes.
That you know, as we mentioned before, you and your team were just freaking out so much that, so last weekend, Carla and I went camping, and guess what we took with us?
Your Starlink!
We took our Starlink with us. So
That's awesome.
We were in the forest. We had a good view, though, of the whole sky. So we were in sort of an open, clear space. We had a good view of the sky. And, worked like a charm. Except we didn't take any way to power it for very long. So
noob.
Noob. This was just an experiment, right? So Carla has a in her truck, she has a plug in the back of the truck that you can plug in. It's like an inverter built into the truck, and it gives you 150 watts out. So as long as we turned the car on, we had super fast internet. And so I quickly downloaded like a whole bunch of shows onto the iPad and then turned off the car. But yeah, it worked great. Worked like a charm. Yeah.
So I'm going to guess that if it's built smart, as long as you're only pulling data batteries should last a while, but
No.
pushing,
No,
it's going to be a hungry beast.
No, it's hungry the whole time. It's
Oh,
using
man.
between 90 and 110 watts nonstop.
Okay.
So it will guzzle, like you need a generator or
Yeah.
a pretty fancy solar array and battery backup to be able to run it for a long period of time.
So my MacBook Pro, I want to say, is like 80 watts.
Yeah, so like but like your MacBook Pro, I don't know if you have one of the new ones.
It's like 2 years old.
Okay, so the new ones will run 20 hours, right, on a charge. So you can run, you plug it in and then you run it for 20 hours in constant use, playing videos or whatever. This thing, like, it will guzzle a regular battery in about 2 hours, like a car battery.
Yeah.
So you would need a pretty fancy, I sort of did the math, and you'd need like a couple of $1,000s worth of solar panels and battery backups to actually just have internet wherever you want it to go, or just bring along a gas generator. So we're not quite there yet. It would be interesting if they had like a low power mode, because even if it was just even a couple of 1 megabit per second, that would be great. As opposed to 200, like just fast enough for me to be able to check my email and so on. And so,
right.
It'd be interesting if they could offer a low power mode, because the dish feels warm enough that it melts snow. Like you feel the heat coming off the dish. You feel the heat coming off the power pack. You feel the heat coming off of the Wi-Fi router. Like there's a lot of heat going on in the entire system. So this is clearly, we're well into prototype land so far, and I can imagine some kind of future where it's better. But I think that if you've got some place that is off grid, and you do want to bring Starlink, you're going to need to bring a pretty serious power system with you to be able to make it go. How McCabe, is camping with Starlink really camping? Yes, it is. Yeah, it totally is.
What gets me is like the Stellaris telescope runs off of a USB battery.
Mm-hmm.
My computer runs off of a USB battery. They just need to get Starlink so you can run it on backup off of a USB battery. But right now it's just not there.
No, it's not. You need, I've been looking into it. There's like a couple of like battery packs that are like 1,200 watt hours of battery life. So that's 12 hours. And the thing is like $2,000. And then if you can buy like 140 watts of solar panels for another $600. And so if you put those two up, then you would get mostly full time with your Starlink for $2,500, which seems like a lot.
But so like Richard Drum, who does our video editing, he has a really nice electric bike that makes it clear to me that as I get older,
you want one of these.
I live someplace flat. I'm in the Mississippi floodplains, so I've got time, but he has solar panels that he can pack along and recharge his bike. And so there's this really cool future where I can see us, because solar panels have improved so much, being able to go trekking on our bikes, carrying our Starlinks with us, and hopefully
there's a car that I've been looking at called I think it's called like the Aptera or something like that, and it's like got 3 wheels, and it's got solar panels on top of it, and it's got this weird flat design that looks reminiscent of an Australian solar panel car race that a bunch of university students have run, right? It's the weirdest looking car, but you can buy a model that has 1,000 kilometers range and has enough solar panels built in to essentially recharge itself nonstop. And so you could just have a car that just drives all the time forever. and you never
Yeah.
recharge it, and you never have to do anything, which is super cool.
There was
yeah.
a solar powered plane as well that they pulled that off with.
Yeah, NASA had one that went
Yeah.
around the, like, I think it was flying for months on end on solar power. Yeah. This stuff is all really exciting. I do love it, and so, like, on the one hand, it's super exciting with the Starlink to be able to just have high speed internet wherever you go. It's a total game changer. And, obviously for me, it's camp and be able to still do my job, right? Camp in style, as it were. But for a lot of people who are just in remote communities that have never had access to the internet, but they do have
Yes.
power, then this is serious business. I think I mentioned this last week, or I forget where, but that my parents on Hornby Island, they're one of the lucky ones who have some internet. And so they have like a 5 megabit connection, 1 megabit up. There's been a few times in the past when I've tried to do live streams from their house, and it's barely possible. But a bunch of people on the island who could never get internet, like the local telcos just said, suck it, right? And so they got Starlinks, and now they're lording it over the rest of the island, because now they're the ones with the fancy internet. It's pretty funny.
Yeah. And the thing is that while the bandwidth and energy consumption was completely overkill for camping for you and your spouse, if it's a library in a remote place, that's a classroom's worth of computers.
Yeah, a school.
Yeah.
Totally.
And so now we no longer need the one child, one computer laptop program.
Right, one laptop per child.
Yeah, exactly. Where they were trying to do distributed networking. Now we can just have that network and just give them ebooks.
Yeah.
It's fine.
Yeah, one satellite uplink per community, per town. It would be a good way to start. And so it's, I think it's, so far, and in theory, the service will get better and better and better. And I hope that the actual technology for sending and receiving to the satellite dish, that's the key that I hope will get a lot better. And it is weird that still, like, one light bulb's worth of power is still too much to be able to take it on the road. We're just not there yet.
Yeah.
So, yeah.
Yeah, one old school light bulb. You shouldn't be using light bulbs that use that much power anymore.
LEDs
just
now, yeah.
Have to be clear there.
Zapfan wants to know, Pamela, what happened to the Earthworm?
All right. So the reason that you're encouraged to launch grasshoppers and such is they have exoskeletons that hold their shape under the extreme G-forces of a launch.
This sounds like a sad story.
Earthworms have no exoskeleton. They don't withstand very much squishing. And that's all I'm going to say on the matter, other than mistakes were made.
Right.
I was a child.
Right. Oh, that sounds scary.
It wasn't scary to me. It was just a bit gross and required a hose.
Right. Actually, a bunch of people had a similar question, so I think we've been able to. All right. So Hal McKinney asks, sound has a speed limit because it requires a medium of air to exist in. Shouldn't the fact that light has a speed limit be a line of evidence that there must be a medium for light?
People have made that argument many times over the past 2 centuries, but it appears that light is, because it's carried by photons rather than by oscillating the existing medium, which is what sound does. Sound is the propagation of energy through a medium. Light, the particle itself, is what's doing the propagating. It's a particle and a wave simultaneously. So it's that switch from energy moving through a medium with sound to a particle doing its thing that allows light to not require a medium.
Right. And what was the name of it? The something ether. There was like a word. starts with an M. Someone in the chat will probably be able to mention it. But this was theorized back in the 1800s that there must be some ether. And then through the process of quantum mechanics and understanding how photons work, that the ether was unnecessary. And every now and then somebody puts out a science paper saying that they have proposed some kind, luminiferous ether. There you go.
Yes.
So Hal McKinney, do a search for luminiferous ether, and you'll find more information about this. So this is that was a serious theory and was disproven, and it's what you would expect because of the way sound works, and the light moves in waves just like that sound does. Oh my God, I was going to say something or bring up something. I forget now. Never mind. Oh, right. Mushrooms on Mars. Have you heard about this?
Wait, what?
So a science paper is proposing that there are mushrooms, there is evidence of mushrooms
today.
On Mars. Yeah, like
right now.
Like, yeah.
Not lichens, mushrooms.
Mushrooms, little growing mushrooms. Yeah. Go ahead and do a search for it. It has been poorly received by the science community and lacked rigorous peer review. But yeah, I would be prepared. I would be prepared to get a lot of questions about mushrooms on Mars.
So what I'm loving is the set of headlines that popped up. Popular mechanics. Scientists believe these photos show mushrooms on Mars and proof of life.
Yeah.
CNET. No. NASA photos are not evidence of fungus growing on Mars. Sorry.
Yeah.
Futurism. Scientists claim to spot fungus growing on Mars in NASA rover photos.
Yeah.
It's just sort of like, okay, let's.
Yeah. Universe Today. Crickets. None of my writers have asked if they can tackle Mars mushrooms. So
there's sometimes stories that get past peer review because there's nothing specific in them that you can say, yeah, this is full of shit.
I am now of the opinion that peer review is a farcical sham. There you go. Farcical sham.
There are good times where if it is done by a good individual, they will read the paper and go, oh, you screwed up your stats here. Go fix this before it's published. Or, hey, did you think about this thing that will actually really change your interpretation?
Yeah.
And peer review is there essentially as let's just poke this with a few extra sticks. And if it doesn't fall over, publish it.
Peer review is not what you think it is.
Right.
Yes.
Right.
Yeah. Peer review is not you write a paper, your peers look at the paper and try to bang holes in it and toughen it up. And you have to go through this gauntlet of peer review before the journal will accept your paper.
So it can be. Unfortunately, there's people who've built different names for themselves. And because peer review isn't anonymous, it's much harder for them to get their work published. There are other times where someone's just having a really bad day and you could have the best paper in the world and it's going to come back spat all over and make you cry. And then sometimes the person who's reviewing your paper just doesn't know what they're talking about and your paper gets rejected.
Yes.
Yeah, it's a hot mess is what it
really
is.
Yeah.
And
so it's interesting to sort of, as I've, people, when I sometimes would report on stories in archive, in the pre-press, preprints, people go, well, that's not peer reviewed. And normally I'd be like, I'd be like, oh my God, I'm so sorry. I didn't know that it wasn't peer reviewed. I'll only report on peer reviewed stuff. And now I know better. That's not peer reviewed is like saying, I don't know, that hasn't been sprinkled with pixie dust. I don't care.
So it depends on what the results are.
Yeah,
there's some things there's some things you and I have the skills to look at and go, this paper will survive peer review. It may end up with some changes along the ways, but these preliminary results I'm going to talk about. And there is stuff that comes out of theoretical work for me that I'm just like, Maybe.
Yeah.
I don't know.
Well,
Not qualified.
in the immortal words of Dr. Paul Sutter, if it's interesting, it's probably wrong.
Not entirely true.
Right.
Often true.
Yeah, that's all. And so if you're like, wow, that's really cool. Mushrooms on Mars, you say, it's probably wrong. Yeah, just
Oh,
go
man.
with it's wrong. Yeah, probably. So it's biosignatures on Venus, phosphine in the atmosphere of Venus.
That one just makes me angry because like they did everything right except reduce their own data from scratch.
The M drive that violates the laws of physics to give you
That one
continuous
annoys
thrust.
me.
That's interesting. Yeah. Yep.
Yeah.
So again, whatever it is, muon G-2 experiment showing that our current understanding of physics is incomplete.
My
Probably
favorite
wrong.
bad paper so far was one a number of years ago. It may have even been like 15 years ago at this point. Looking at the ability to have sound waves in water hitting together and generating fusion at room temperature.
Probably wrong.
And they used Ben and Jerry's equipment to run the experiment in.
Like ice cream makers?
Yeah, so there was like something they had that got used or it was identical to. And in the explanation I read of it, it was inspired by the kind of shrimp that aren't actually a shrimp and their claws close so fast that it generates light. Mantis shrimp.
Yeah, mantis shrimps, yeah.
Yeah. And it was just one of those, you're not going to generate fusion this way, but this is super cool. It's just like,
yeah. Who knew that mantis shrimps were the masters of fusion?
I know. It was kind of wrong.
Neutrinos
and awesome.
Go faster than the speed of light. Probably wrong.
No. Although I have to admit, I'm starting to get to the point that if someone were to walk up to me with even the smallest modicum of evidence that neutrinos are dark matter, I'd be like, yes, I'm down with that result. I'm there, man. I'm ready for that.
It was interesting. Sabina Hassenfelder did a great video just a couple of days ago about how she's not so convinced that dark matter is a particle anymore.
Oh,
yeah. And I'm going to spoiler alert the video because where she gets to is it really looks like in her mind that it's a combination. And that's why it's been so tricky, is that it's a combination of gravity working in ways that we don't understand, but also some kind of particle. And so it's because the two are so mushed together, it's really hard to tease out which it is. And actually, I had a great interview last week with Rebecca Lean and talking just about dark matter and methods of detecting dark matter. And I always like to ask people, like, place your bets. What's dark matter? And she, as a person who searches for it, says, I think it's all kinds of things. That matter is all kinds of things. Energy is all kinds of things. So it wouldn't surprise me that dark matter is all kinds of things. And that we're going to find one thing that explains dark matter, and that's one little piece of it, and then we're going to find something else that's totally different that explains another little piece of dark matter, and that we will be unraveling dark matter for what it truly is for a very long time.
One of the things that I've started saying a lot on Daily Space, which I really need to go record in a couple of minutes.
Yep.
One of the things I've been finding myself saying a lot is the universe is far more creative than we are.
I like that.
And the answer is always yes and.
That's so cool. Yeah, I think you're exactly right. And the more we embrace that.
Yeah.
That's what makes science so much fun. Like, it's when people want certainty, it just drives me berserk. I enjoy the back and forth. I enjoy the overturning the results, the nuance, the shades of gray. I think it's super fun and makes it interesting.
And it's not a binary paradigm with a single answer anywhere.
Yeah.
It's people for decades talked about, our galaxies formed from the bottom up or the top down, and the answer is yes, both.
Yeah.
And I love that.
Yeah. Super cool.
But I
You gotta
do
go.
need to.
Fine.
Yeah.
Yeah,
So
no,
let
absolutely.
me prime Keeper. So those of you watching on YouTube, head on over to twitch.com/CosmoQuestX.
TV. I'm assuming it's TV. Twitch.tv.
Yeah,
CosmoQuest?
twitch.tv/CosmoQuestX. And I will be there in just a moment, putting together all that's new in space and astronomy. Fraser, today was a day full of joy. We need more episodes like this.
Absolutely. All right. We'll see you next week. Thanks, everybody.
Bye-bye.
Find the button. End the stream.